Hey there, I'm Lyndon. I decided to do my final report on the Yelp dataset. We all know what Yelp is. It's a crowdsourced business recommendation site used for restaurants, sightseeing, whatever your thing is. But more importantly, for the terms of the dataset, it is somewhat of a social network. There are profiles for businesses and users, and these profiles contain typical social network information like profile pictures, friends, but in this case it also contains ratings and reviews, which are a really interesting metric to measure how users and businesses interact with each other. Yelp started releasing this data about 7 years ago as part of a dataset challenge. You can win $40,000 if you win, but usually it's research papers you win. I thought it was really interesting and clean because it had this really nice looking data on their web page, but it turned out to actually look like this, just these horrible, massive, like gigabyte text file mess of unorganized CSVs. It was terrible. But anyway, one of the first things I mapped when I looked at the dataset was the average rating of both users and businesses into these simple buckets: 1 to 2, 2 to 3, 3 to 4. And I found it interesting that there's this most values for both users and businesses in terms of average rating are from 3 to 5 stars, and with almost the exact same distribution. And that could be expected to some degree, but I decided to investigate it a little more. Here I've mapped users' average rating into more specific buckets, and across the y-axis there I'm mapping number of friends, and you can still see the same distribution here, where the people in that 3 to 5 range have the most friends. And when I change it over to number of reviews here, that distribution stays relatively similar. So what this tells us is that these are the people in that range are the people participating most in Yelp by a very large degree in terms of number of friends, number of reviews, and to some degree it may be biasing the data because just simply there's so many of them. So when we filter out people who have less than 30 reviews, you can see that the data becomes significantly more normalized. And what this tells us, just very obviously here, is that this data is biased by the people in that bucket. And we'll see here with this parallel distribution chart. Here in the columns I've mapped the columns so that every other column represents a particular user's data, a user represented by one line, and then the next column represents that same data averaged out for all of his or her friends. And so you'll notice across this data that it's very biased in favor of people in that 3 to 5 bucket again. They just participate so much. They have so many friends. They have so many reviews that the data from everyone else outside of this bucket, you can see that I've marked them very specifically with green and that they are the only color present in the later columns. They're the only people we can really see in this data. And while that's somewhat expected, if this is the group of people, the people who are going to participate most, who are going to be the people giving 2,000 reviews a year, have 500 friends. Obviously, they're going to take up most of the data, but Yelp is a recommendation service, so this does show that Yelp data is biased. Here I've taken out some of the people with a larger number of views, and you can see that the table again immediately balances, and you can see more blue and more yellows and oranges throughout the rest of the chart. And this is just number of reviews and number of friends, but I think this is a really good example of how biased Yelp data is towards the people who use it most, and how that population decides what Yelp likes.